Welcome back. We've made it through our first set of labs. We have looked at the user interface. We've looked at how to deploy the NSX managers. Well, what's next? The data plane. Getting the data plane all set up and ready to go is, well, that's what we've got going on here. So we're going to talk about transport zones and transport nodes and virtual switches and how NSX is going to interact with those virtual switches. We're going to talk about other infrastructure components like IP address pools and uplink profiles and things like that. There's a lot of stuff going on. There are a lot of pieces of this particular puzzle. So we're going to break this topic up into a couple of different videos here. So stay tuned, right? We're going to make it through some stuff here. We're going to take a break. We'll make it through some more stuff after the break. So when we think about preparing the data plane, what are we preparing? Well, we're preparing the ESXi hosts. We're preparing bare metal servers. We're preparing edge nodes. And this is providing us our distributed scale out forwarding engine, right, is really what we're doing here, where the individual virtual machines are able to use resources local to them, right, meaning that as I add more hosts, I add more capacity. Now, a transport node, like I just mentioned, could be an ESXi hypervisor. It could be a bare metal server, which really encompasses quite a few different modern operating systems, whether they are Linux distributions or Windows. And then the NSX Edge is also a transport node. So we've got a lot of flexibility in what we can include in our NSX domain. So a transport node is made up of basically two components from an NSX perspective. One component would be the local control plane, right? The NSX proxy service that provides the ingress from the central control plane to program out the data plane bits. The other major piece would be the virtual switch, right? The vSphere distributed switch on an ESXi instance. And that's going to provide packet forwarding and packet processing capabilities for that particular transport node. So we've got a couple of different ways that we're going to, or a couple of different pieces that we're going to use to create a transport node in the context of a hypervisor or a bare metal server or whatnot. Now, the vSphere distributed switch, right? If we look at the picture here of the ESXi transport node, we use a VDS there because, well, we've already got that virtual switch on ESXi. On a bare metal server, on an edge node, we're going to use a virtual switch object called an NVDS, an NSX virtual distributed switch. So, we don't see those. We don't interact with those quite as much. We're already very familiar typically with a vSphere distributed switch on ESXi, however, so we call that out differently. Now, a transport node needs connectivity to two types of networks. One is the management network. The other is what we term the transport networks. Now, in the context of NSX, that often means a VLAN that we're going to use to carry our overlay traffic. But that could also mean the transport network could also mean, the different VLANs that my virtual machines live on right now. There are a lot of options that we may want to look at here. There's a lot of flexibility. I need connectivity to both of these kinds of networks. The management network, because that's where my management components are going to be. That's where I'm going to get my configuration for NSX and so on. And then the transport network so that my virtual machines can send traffic around wherever they need to go. Now, we could connect to these using a shared set of NICs. For example, if my hypervisor only has two physical NICs in it, that would mean that I really need to share those two NICs between my management and transport networks. But if I had enough NICs in my host, right, to dedicate maybe to different virtual switches, for example, maybe I have two physical NICs that get me to my management networks and two physical NICs attached to my transport networks. So we can use dedicated or shared NICs depending on what we have available on our hypervisors. As we're getting ready to set up our transport nodes, we probably are going to build out these objects in NSX called IP address pools. An IP address pool is simply, well, it's exactly what it says it is, right? It's a pool of IP addresses. And NSX can use that when it's saying, when it's creating, say, a tunnel endpoint. We'll talk about tunnel endpoints a little later. But when we're calling to have a tunnel endpoint created on an ESXi host, that's going to have an IP address. We need to be able to assign an IP address. And so NSX will reach into that IP address pool and pull an address and tell the ESXi host to create this tunnel endpoint with this specific IP address. That's all it is, right? An IP address pool is a pool of IP addresses. And then we're going to have to create transport zones. And a transport zone is simply the boundary, the configuration boundary. I'm going to end up associating my host switches with one or more transport zones. And in doing that, when I create, say, an overlay segment in NSX, I'm going to assign that overlay segment to a transport zone. That transport zone, in turn, is going to define the virtual switches on which I need to create that logical switch that I'm going to create that segment on. So I'm going to use these transport zones as essentially boundaries, configuration boundaries to contain the scope of my logical networking. Now, I can have a single transport zone in my infrastructure, and maybe that's all I'm going to have. Well, I'm going to have more than one. I'm going to have at least one overlay transport zone and at least one VLAN transport zone, because the transport zone is also going to define the type of traffic that a particular segment is going to carry. So when I create an overlay transport zone and I create a segment and attach it to that overlay transport zone, well, that's going to be a logical switch. That's going to use our Geneve overlay protocol to send traffic between hypervisors. Alternately, if I create a segment and associate it with a VLAN transport zone, that's going to be just like creating a VLAN-backed port group on a distributed switch, right? It's just going to be a port group that's going to allow traffic to pass and be tagged with some VLAN ID. So that's another use case or another function rather of the transport zone. So it's a configuration boundary and a configuration tool in that respect. And so, I'm going to have probably one of each, right? One overlay transport zone, one VLAN transport zone. I may have multiple VLAN transport zones. I could have multiple overlay transport zones. It's all going to depend on what it is that I need. Well, come talk to me about a design class and we'll talk about those use cases. But a segment is going to exist in the context of a transport zone, and a transport zone will contain the hypervisors or the transport nodes that need to be configured. Now, here we're kind of showing that transport node to virtual switch association, or transport zone rather, to virtual switch association, where we're going through and associating different virtual switches with different transport zones so that we can have different networking in different places. Now, we use a vSphere distributed switch for the host switch on ESXi. Simply because we've already got a vSphere distributed switch. We're already used to that. That's going to be something that is in our data centers today. It's in our vSphere infrastructures today. vCenter is managing that distributed switch, and we're familiar with it. Well, there's no reason for us to have an additional virtual switch type on ESXi for that. So we're going to leverage the vSphere distributed switch. You'll see our NSX segments presented through vCenter as NSX port groups on that distributed switch. And we'll see that looks just like any other port group, except the icon has a little N stamped onto it to kind of identify that, yes, this is an NSX port group rather than a vCenter distributed port group. Now, the NVDS or NSX virtual distributed switch is a host switch construct that we're going to use on bare metal servers and on our NSX edge transport nodes. And we're going to use this on those different transport node types because, well, simply put, there's no vSphere distributed switch on those. So we have to have some kind of virtual switch to provide for that packet processing. Well, the NVDS is what we're going to use on those non-vSphere platforms. You don't have to worry too much about it. It's all just configured as part of NSX, and we don't have to worry about managing those individual virtual switches on those individual bare metal or edge transport nodes. Now, to create a transport zone, right, as we're thinking about all of these constructs, to create a transport zone mechanically, it's pretty straightforward. Under the System tab in the NSX UI, I can go over to, I can expand out rather, the Fabric header in the navigation menu on the left, and there's a Transport Zones menu right there. I can click on that and click on the Add Transport Zone button. And the only thing I need to create a transport zone is I need a name for the transport zone object, and I need to define what type of traffic this transport zone will carry, whether it's going to be overlay traffic or VLAN traffic. That's it. I can create as many transport zones as I need. Less is typically the preferred number. Fewer transport zones is typically preferred, but we can create as many as we need. And you'll notice there are two defaults out of the box, right? When you deploy NSX, you're going to have a default VLAN transport zone and a default overlay transport zone. You could use those if you so desire, but you cannot modify them. So, the names may not be appropriate for your infrastructure, for example. So we can create transport zones as necessary. Once we create them, we can see what type of transport zone they are. We can see the status of the transport zone. Now, you'll notice here in this picture that the default transport zones both have a status of unknown. Well, they have a status of unknown because we're not actually using them anywhere. The prod overlay TZ and prod VLAN TZ transport zones are both used in host preparation, so they both show a status of up. The unknown status simply means that we're not using these anywhere, so we don't know what the status is. They're not actually realized anyplace out in the data plane. Now, as we are configuring our transport nodes, our hypervisors, our ESXi hypervisors in particular, we may want to worry about, or may have to worry about, the operational mode. Now, this is under the advanced configuration. If I'm building out a transport node, this is under my advanced configuration here that we're highlighting. So this is not something we often have to worry about. The default is the standard operating mode. But we may want to think about this in the longer term, right? We may have reasons to use one of these non-default operating modes, right? So the standard data path, this is the vSphere distributed switch data path that we have known and used, well, since the inception of the distributed switch, right? These are things that have been around. This is a data path that's been around for a long, long time. It works just fine in most cases. The enhanced data path for performance, right? So we've got the enhanced data path standard and enhanced data path performance. The enhanced data path performance is specifically used in a telco type use case where, if you think about use cases where you've got an excessive number of very, very small packets running through your virtual switch. Now, the enhanced data path performance is enabling Intel's DPDK functionality on our virtual switch, on the virtual distributed switch. And that's going to require some additional configuration. It's going to require some processing cores to be dedicated, some CPU cores to be dedicated to packet processing. It's going to require very specific network adapters on the compatibility guide. We want to be careful with using this, right? If we don't need it, don't configure this. It's overcomplicating your infrastructure for no significant benefit. The enhanced data path standard may be an option in the data center, in an enterprise data center, if I'm running into perhaps packet processing challenges with the standard data path. Some of us are going to be in that position, and that might be something to look at. Now, it's worth noting that the system requirements and the compatibility requirements of the interrupt data path, the standard enhanced data path, are not as stringent as the performance enhanced data path, but I do still have network adapter restrictions that I have to worry about. So go double check the hardware compatibility guide before you choose anything other than the standard data path, right? The standard data path works with your existing vSphere infrastructure. That's what we're going to use almost every time, right? Almost every time. So we're going to take a break here. We're going to wrap up this first section of the video. We'll come back here in a couple of minutes after a break and dive in through the rest of our transport node preparation. But what have we gone through so far? Well, we've learned that transport nodes can be ESXi hosts. They can be bare metal servers, which could be Linux or Windows, and they could be NSX Edge transport nodes. We've learned that transport zones define the scope of configuration for our network objects, and we've talked about the distributed switch and how that is going to be assigned to a transport zone and provide host switching on ESXi. Right? Those are the three big things we want to think about from this particular section. Now, come back in a couple of minutes after you take a break. We'll wrap up transport nodes.